comments. Johannes, would you like to introduce the Turnkey project, please?
Of course, one has to switch on the micro. Thank you very much, Celia. And yes, my name is Johannes Schweitzer, and I'm the coordinator of the Turnkey project. And I would like now to share my screen with you for a couple of slides. And so let's see, we can go here and take this here. I hope you see now the presentation. And
yes, we do.
We see.
So I don't know if I should keep this. Okay. Good afternoon, everybody, and I would like to give you a short overview over the Turnkey project. The Turnkey project started approximately 3 years ago in 2019, and it's close to its end. The title is quite long, towards more earthquake resilient urban societies through a multi-sensor based information system enabling earthquake forecasting, early warning and rapid response actions. Sounds very complicated and long, and therefore we also internally are only using the acronym Turnkey. The Turnkey Consortium consists of 21 partners from 10 different European countries, and you see all the logos of the different partners, partner institutions here on the map. And these 21 partners are from universities, industry partners, and research institutions. And the main project outcomes are 2 fully operational products, what we were planning 3 or 4 years ago. These are the low-cost multi-sensor units at the different for measuring different things, and the Turnkey Earthquake Information System. And my talk will mostly concentrate now on the Earthquake Information System and not so much about sensor units and sensors. The Turnkey project tries to follow the different stages of an earthquake crisis. Usually, before an earthquake occurs, one can prepare and get prepared for the situation that maybe a larger earthquake occurs in this and this region. One is collecting earthquake hazard information, for example. One can make different scenarios and prepare the buildings and all these types of preparations. Then the next stage is that we have the earthquake occurring, and then, of course, the earthquake early warning is a very important point, that in particular near the earthquake source, people are getting as fast as possible informed that maybe they are coming larger or big shaking to their place, and that they can take action and with this reducing the impact of the earthquake. And then, of course, where we are concentrated quite a lot on was the rapid response after an earthquake to support people with information about probable damage scenarios in their area. And of course, then after the earthquake is again before the earthquakes, and therefore this is a quite cyclic process. Now I have to click here. For this, we developed the Turnkey Concept, which is consisting of low-cost multi-sensor units, which are consisting of conventional seismic networks, of specially installed sensors in buildings or to monitor structural behavior, and also includes the usage from information from smartphones, from people observing things and reporting it via, for example, the well-known Did You Feel It systems, or the applications running by the EMSC. And all this information is then going in what we call the turnkey engines, which are at the end a suite of programs analyzing and calculating numbers and analyzing the results from the different sensors, and giving this information further to eventual decision makers and people who are working as responders, as first responders, and giving this information further eventually to the public or business or critical infrastructure operators. And for this all, we developed software and tools and graphical user interfaces, which are then set together and working together. Then we had in this project 6 test beds in Europe, 1 in Iceland, in the Netherlands, in France, in southern Italy, and in Greece and Bucharest in Romania. And all these test beds were selected because the social situation in the different test beds is quite different. The seismic hazard is quite different, and also the geology and the general structure in the areas is quite different, the density of population and so on. So to collect information and to get very different scenarios in the platform to test our product, our turnkey product. And what we were doing, we were testing real-time streaming of multidisciplinary data from seismic data, deformation data, structural response of buildings. And this all was then used, or this we implemented then in the usage of the engines, of the calculations of the potential risk which happened due to the earthquake. And our project followed a quite usual life cycle. We started with, at the end, with interviewing and trying to get information from first responders, critical infrastructure operators, public and business people about what they would like to have in such a case as a product, as some information. Then we installed instruments for real-time data from the test beds. Then we made quite a lot of efforts to collect state-of-the-art algorithms, which we then implemented in the platform and developed further these algorithms, which we then all connected in the engine, which was then taking all this information together to produce maps and to produce fast information about an earthquake scenario. And how this again then was presented with the help of a graphical user interface was then again shown to the people we interviewed at the beginning, and we asked them what are they now thinking about the outcome of our efforts. For these end-user requirements, we made in-depth interviews with the civil protection and first responders in Bucharest and Patras and Reggio Calabria, and in 3 rounds. And in this context, we asked people from the civil protection, fire departments, and operators of control rooms, and asked them for information at the beginning of the project and at the end. And what came out was that the planned output of the project that would be very helpful to get impact maps as a response of an earthquake, larger earthquake, to identify priority areas where maybe some damage can be expected, where maybe streets are blocked or lifelines may be destroyed, and also to use the platform to prepare for future scenarios and to play through the possibilities. If an earthquake may happen there and there, what will be the impact on this and this structure in this and this area? And what was also then installed were the possibility to send out automatic alerts to critical infrastructures or to people if needed. And yeah, the idea is that an app could maybe save life by identifying people which are in rubble somewhere below or such things. So all this was discussed in advance, and what is now really what we achieved as innovative progress and innovative result of our Turnkey project. And that is first the ability to simulate scenarios and then to see the real life impact over larger geographical areas, compact pictures of possible impact and damages on maps. And the platform can share this information across different people involved in such a rescue situation or need for rescue situation, and helping to communicate the results or the probable impact of the earthquake between different players in the safe and rescue situation. And therefore, we are saying that using the Turnkey supports end users save lives by increasing the accuracy and timelines of the response. Importantly, for the end users, is encouraging a change of approach from reactive to preventative behavior. And there we would like to cite 3 of our first responder people we asked, and after we showed how the whole platform is working, they gave us as feedback, for example, the Turnkey platform will significantly reduce the time needed to coordinate, and we have an immediate response ready within minutes, and which is very critical in such situations. Or seeing everything on a platform would make things easier, or it would be extraordinary to have this information successfully to regular intervals, and it's actually the hardest part of the operation. So we think we were going with our project in the right direction. So the status quickly of how the situation is. As I said, the Turnkey platform consists of 3 main different parts: the instrumental network, then this scientific engine, which is calculating and using the information from the network, and the end user interface. And the main features which are now working is integrating data from existing and conventional seismological networks, strong motion networks, structural monitoring system, GNSS sensors, as well as smartphone-based networks and observations from eyewitnesses. And this allowing a near real-time analysis of all this information and providing actionable output for stakeholders. And the stage of the platform, the development stage after these 3 years, is that the technology had been validated in relevant environment, and we are looking forward to find places where one could implement the platform in real life and not only in a project context. And with this, I would like to thank you.
Thank you very much. I think you presented it very well. It was very interesting how much the end users actually could place the product in their own operations and how much they could see it actually contributing to what they do. Okay, so I would now like to invite Konstantinos to present the REDACT project, please.
Thank you, Julia. Just a moment to start to share my screen. Okay, and start the presentation. In a moment. I think that you can see my presentation, but not from the first slide. Is it okay? Perfect. Thank you. So welcome everybody. Thank you for being here. My name is Konstantinos Papatheodorou. I'm the REDACT project coordinator, and on behalf of the project partners, I would like to present the REDACT, let's say, suggestions for improving earthquake risk mitigation with decision supporting systems and risk awareness actions. First, a couple of words for the project, some details. It is being funded by the European Union through the Black Sea Basin Joint Operational Program 2014-2020. The partnership consists of the International Hellenic University as lead partner, the Institute of Engineering, Seismology and Earthquake Engineering of the Earthquake Planning and Protection Organization of Greece, the Demokritos University of Thrace, Greece, the Gebze Technical University, Turkey, Ovidius University in Romania, and the Institute of Geology and Seismology of Moldova. The project lasts for 30 months. And the total budget is near 1 million euros. Well, the targets of the project. We all understand that during earthquake-imposed emergencies, crisis management structures need to know what has happened, where it has happened, the location, the extent of the damage, assets affected, lives at risk, and so on. So, in other words, they need situational awareness. Once the problems have been identified, then they can prioritize actions, allocate resources, and finally intervene, dispatch forces to respond to the problems. According, of course, to the existing protocols, and we should always keep in mind that except from the civil protection services and state authorities, the public can play a key role in the process of mitigating disaster risks. Having said that, the public also needs situational awareness, and even more, it needs capabilities to comprehend the risks and react accordingly. The response capacity of the population can also be improved if the necessary education and training is provided in a simple and comprehensible way, of course, and also tools are provided to disseminate reliable information during those critical moments. With those conditions met, all involved are expected to have an improved behavior during emergencies, always in line with state emergency plans. So the targets of the REDACT project are to support informed decisions regarding planning for prevention and preparedness, to provide situational awareness during emergencies to authorities, all that, and to improve public response, always in line with state emergency plans. For some reason, okay, it will move forward. The suggested way to do it is by developing a rapid earthquake damage assessment system, which consists of a rapid earthquake damage assessment platform, like the one we have seen, a smartphone app, and an educational hub. The rapid earthquake damage assessment platform will provide damage level. At the left, you can see damage level, and as damage, we include the building stock, infrastructure, and geotechnical failures, including landslides, liquefactions, which can seriously affect safety. So it will provide damage level in the case of scenarios, helping in this way to plan for both earthquake disaster prevention and preparedness. And also it will provide damage level in near real time by processing real-time data from the combined existing monitoring networks in the area. This rapid earthquake damage assessment platform will cover all areas, including cross-border areas, where ground motion parameters, for instance, will be calculated, taking into consideration measurements from both sides of the borders, improving in this way the accuracy of the ground motion parameter calculations. In locations of interest, ground motion parameter calculations will be further refined by adding to the monitoring network low-cost accelerometers installed in existing buildings. We are already working towards that end in 30 school buildings in Thessaloniki and another 5 in Seris, northern Greece. To improve public response capacity, to comprehend the risks and respond efficiently, REDACt project will contribute to efforts already made by existing institutions and state civil protection authorities by, first of all, we can see it at the middle, smartphone app, which will provide evidence-based risk information and guidance to the public. It will support it during emergencies and improve awareness and response capacity. It will also give the public the ability to provide feedback and reports during an emergency situation. And we are trying to include some additional abilities, as for instance, the ability to provide to the public important information during a crisis, as for instance, could be the on-demand location of persons of interest, family members, for instance, loved ones, and predefined locations by state authorities where they can find refuge and assistance and so on. The project foresees the development of an educational hub, additionally to those, which will provide guidelines, best practices, tutorials to help the public develop their own emergency plans at various levels, for instance, personal level, the family level, and so on, always in line with state emergency plans. The REDACt educational hub, as I said, will contribute to the plethora of material, of existing material towards providing the required education and training in order to raise the public awareness and help the population to improve their emergency response capacity, to better coordinate with the authorities, and in this way to improve the overall emergency response efficiency and public safety. Educational material and an indicative list is shown in this slide will be produced. Electronic lessons targeted at experts and staff of the administration will include detailed information on the REDACt system, platform, smartphone app, and so on, and its efficient use to improve emergency response, whereas towards the less expert part, let's say, of the target group, population, volunteers, and so on, popularized principles and guidelines to support the development of their own emergency response plans, as I said, at various levels, with the assistance of the smartphone app, which is being developed, and with the REDACt, the project website and educational hub. Well, let's see about the implementation status. The project lasts for 30 months. We have already spent almost 20. At this point, we feel like having just climbed out of a pit after 8 months of working with administrative tasks, submission of reports and extra reports and so on, and clarifications. So anyway, we're now at the point that we have actually achieved, we have built a framework, first of all, a framework for data and information exchange, both on demand and in real time, And it has been jointly developed by all partners. And this was a very demanding task because it required harmonization, and it's based on trust and respect among the partners. And this is the foundation, let's say, on which everything else is being built. We have also finished with the harmonization of methodologies for hazard and risk assessment. That was a demanding task too. We have selected and tested and evaluated the geotechnical failure modules, which are going to be incorporated into the system. We have developed and constructed ourselves the low-cost accelerometers, and we have already selected 30 school buildings in Thessaloniki, northern Greece, and another 5 in Ceres, another city in northern Greece, which have been selected based on various earthquake ground motion and building response, let's say, properties, parameters. A pre-release of the smartphone app has been developed, and development is continuing. And the pre-release of the REDACt platform is under development. We hope that within the next, let's say, 15 to 20 days, we will have something which will work and on which we will be able to work and test. And of course, educational material is being developed as we speak. Very soon, it will be posted on the project website. Before finishing, I would like to express our gratitude to the large number of stakeholders who are supporting us, even since the preparation of the proposal. And they include, but they are not limited to, state authorities, organizations, research institutes. All of them have expressed their interest and supported this effort. Just to mention a few: the Hellenic Ministry of Interior, the sector of Macedonia and Thrace, the Ministry of Education, the Regional Directorate of First and Second Degree Education, the Earthquake Planning and Protection Organizations, after all, it's a partner in the project, the Disaster and Emergency Management Presidency, AFAD, of Turkey, the INFPO NIEPO, the National Institute of Earth Physics, based in Magurele, Romania, which strongly supports this effort and contributes in any way possible. They are not partners, but they are major stakeholders and great supporters. The Regional Administration of Kendriki Macedonia, its Civil Protection Directorate, the Regional Administration of Anatoliki Macedonia and Thrace in Greece, again, Civil Protection Directorate, municipalities of Thessaloniki, of Xanthi, of Kocaeli, Chamber of Engineers, and so on. We are very grateful for their support and help, and it motivates us to provide even more than we have promised. And we are also grateful for being here and thankful for you for organizing this event and for all the participants. So thank you very much for your participation and attention. For more and continuously updated information regarding the project, please visit the REDACt website, and you can see the link right here. Thank you.
Thank you very much, Konstantinos. Very, very interesting. As a behavioral scientist myself, I am very fascinated by your emphasis on dialogue with the general public and the on-demand information. I think that's a very interesting area of development.
Thank you.
Okay. So I would now like to invite Vlatko to take the floor with an overview of crisis.
But anyway, hello to everyone. Yes, my name is Vlatko Sheshov. I'm coming from the Institute of Earthquake Engineering and Engineering Seismology in Skopje. So I'm very happy to be here and to present for the whole team of Project Crisis some of the information and achievements that we have so far with the Crisis project. So Crisis project partners, we are actually not such a big consortium. We have 5 partners, ISIS, where I'm representing as a coordinator. Then we have Crisis Management Center of the North Macedonia, Polytechnical University of Tirana, Faculty of Civil Engineering, then Aristotle University of Thessaloniki in Greece, and Centre from Pavia, Italy. So I will try to follow the structure of the project, then it will be much easier for the rest of you to follow what are the main objectives and goals of the project. So crisis actually is concentrated for collaborative research to preventing and preparedness for disaster risk management in the cross-border countries located in Western Balkan region. Probably most of you know that this region is very known in its history about the seismic events. Then one of the activities that are main activities within this project is first to assess what are the natural hazards and risk of basic services and transport infrastructure. Then to collect, harmonize, and improvement of existing results and data for assessment of critical assets. And the third, let's say, main activities is to develop and testing the methodology which should be incorporated in the friendly web-based platform for rapid screening of vulnerable infrastructure nodes within the region. And what we are expecting as a main outcomes, it should be the improvement of the cross-border risk assessment for the identified cross-border risks, and of course to have joint data sharing tools or platform should be established. So these were, like, as I mentioned, as an input into the project, or what were the main outcomes of this project. So now, as usually all these projects, it has its own structure. I will try to focus on only on some of the working packages that are interest for the wider audience. So I will focus on working package 2, 3, 4, and some slide about the working package 4. Just to mention that this project started almost 1.5 years. It is in the 30th of October 2020, and end date is this year, also the end of October. So we are almost in the latest phase of realization of all the project activities. So far we have a lot of deliverables and a lot of achievements, but also there is plenty of tasks that should be done in front of us. So what are the current situation in this region is that, as you probably know, Albania and North Macedonia are not European, not member of European Union. So this is quite important to be emphasized because, for example, still in our countries, like Macedonia and Albania, the Euro codes, or in our case, Euro code 8 is not still in fully implemented. So we have, as we call, parallel use of these Euro codes. Then, for example, in North Macedonia, we have developed national annexes for EC8. These are the seismic zoning maps. Regarding the cross-border region, the current situation that even there was a lot of efforts, but still we don't have harmonized regional seismic hazard assessment in this region. As you can see on this map over here, we have each country has its own zoning maps, which when you come to the border, it's quite different. So you have sometimes funny situation that on the one side of the border, you have, I don't know, PGA of some value, and on the other side of the border, you have different PGA, which is a little bit strange, you know, because the earthquakes doesn't recognize the borders. So one of the tasks in this project is let's put all the data, let's put all the knowledge on the table and among the researchers, and let's find what will be the harmonized regional risk and hazard assessment. So first of all, one of the outcomes of this package is to identify all relevant natural hazards, but related with the functioning of the basic services. Basic services are in our project that we focus on the health facilities, healthcare facilities, and educational facilities. And this was on the one side, and on the second side is infrastructure, transport infrastructure, with the main aspect on bridge structures. So first of all, identification of all these natural hazards that can disrupt the normal functionality of the basic services and of this infrastructure. And on the second aspect is to evaluate their frequency and potential, how they can harm the basic services and transport infrastructure. And what are the results of this package that we already finished? That we have made the seismic hazard assessment. As you can see now, it's quite harmonized. We use the unique seismic hazard model, which is almost the last officially published ESHM 13 model. For some of you who are working in this field, probably you know. So as you can see now, these are some of the maps that we have produced regarding the seismic zoning or seismic hazard assessment in the cross-border region. Since we were using harmonized model for 3 countries, as you can see now, the borders are just political borders because we have quite harmonized, in this case, PGA on the rock foundation on the rock side for different written periods. So this is one of the first input in the later on activities. But not just seismic events were focus of our activities, but also because this region is quite hill and mountain area, we were discussing that also another type of natural hazards can be considered, and this is landslide hazard assessment also was done. But also here I want to mention that the methodology that we are developing here, as you can see, we can use it for different type of hazards, not just seismic, not just geological, but also biohazards. So it means that you can put a different attribute in the methodology, and following some steps that I will show you later on, you can get the risk assessment in the particular region of interest. So that was our intention, to have at least some kind of universal, as I can say, universal methodology or universal approach for calculating the risk of any kind of hazards on particular area. So this is the landslide hazard assessment that has been done for the cross-border region. So I'm not showing, of course, all the results. These are some only one map. The approach is quite known. It is first of all critical acceleration, then soil type, and then one of the main outcome is the permanent displacement that should be occurred for some type of earthquake scenario. So these are the landslide that can be triggered as consequences of the seismic event. Apart from all of this analysis and some kind of research that has been done, we were also quite interesting about, let's see what's going on about the situation in our national disaster management structures. Let's see what are their current obstacles, what are their problems, what are the information that we can gather in order to be much more efficient in the final goal of the project. So we made a very deep online survey. As you can see now here on the right corner of the slide, in 3 countries in this cross-border region, and we contacted the local emergency and disaster management authorities, and also a questionnaire for national emergency and disaster management authorities. So on the local level and on the national level. So I can say that, okay, the response rate of this agency, let's say, so average between 3 countries were more than 50%. So it was quite satisfactory in that sense. So from this information, which are quite important for us, we get very valuable data and information which help us to design the next activities and steps in the project. So what were the main outcomes? So as the first one is that the fires, floods, landslides, earthquakes, and extreme weather were the common type of disaster in the target cross-border region. Then from the local and national authorities, we get that it's very poorly to satisfactorily prepared to understand the official warnings and react. These were results from all target municipalities. Then lack of specific, well-defined responsibilities and lack of timely early warnings as main issue not covered by national or municipality level politics and regulation. Mostly all of respondents say this was like a common reply from their part. Then we have a lack of human potential, institutional and cross-border cooperation, as well as hard access to remote areas where key difficulties that are concerned municipalities are encountered during this type of disaster. So as I mentioned, these are mountain hill areas where you cannot get a very easy access to some heat area. And then was the need for public awareness, to rise up the public awareness and organization of joint training and drills. And also, of course, effective warning system. And as a final information that we get from this survey is that we needed to upgrade the national legislation. So of course, we cannot touch all this information that we get from the local and national authorities, but of course, some of them we can touch and solve with the results of this project. In the working package 4, actually was first to develop the regional database with all the assets that were of interest. As I mentioned, it was health services and infrastructure, but of course, as I mentioned earlier, you can put different type of attributes or assets that you would like to follow this type of assessment. In our case, it was basic services. It was the schools and health facilities. Just for your information, for example, in this cross-border region, there are almost 200 school buildings, 46 healthcare facilities or structures, and more than 740 bridges. These were the main critical assets or exposure model in our analysis. Then we are further going on for the vulnerability assessment of risk assets based on the defined levels of seismic and landslide hazard. We are almost finishing this task, and I can say that it was quite interesting experience because in those 3 countries, we have a different type of structures, bridge structures especially, and so on. So it was interesting how we are dealing with the harmonization of our different type of or different meaning of the structures for the bridges. But I will not go in detail, so we almost finished this one, and developing of the damage vulnerability function database is already developed. Why we need all of this? We need this in order to define the reliable risk scenarios. So one of the main goals of this project is, okay, we will do all this analysis, all this calculation and everything on the basic services and infrastructure, and then we can play with the different earthquake scenarios. So either it should be strong, moderate, or small earthquake, and all this playing will give us what are the weak points in the basic services and critical infrastructure. So this was one of the main goals in order how we can manage or how we can improve the capabilities of the disaster management structures. If there is an earthquake, for example, in southern border of North Macedonia and Greece, okay, if many bridges were collapsed, then we should expect it much better coordination or support or aid from the Greece part. We cannot expect it that the trucks and support will come from Skopje because many bridges on that side will be collapsed. Then we should organize and coordinate the support from our neighbors. So this was one of the things that we should work on in order to have much better coordination among the disaster management institution. This is still ongoing. Then all these results and the data that I was mentioning and presenting will be collected in the web-based platform. The demo version of this platform has been developed. These are some of the technical issue about these technical aspects of the web-based platform, but it's with the web GIS architecture. It will be, we are thinking to be quite friendly, because our end users will not, most probably will not have the same knowledge as we have at this moment. So it should be very friendly, and it should be very easy to work. And as I mentioned, it will be like a playing tool for the authorities for different type of scenario to see or to organize and to manage their capacities and their structures in order to get to support this area when some of these natural hazard, either earthquake or landslide will occur. So this is still in the demo version, but I'm sure that until the August or September, we will have a fully operated web-based platform. And of course, regarding the dissemination, this is one of the way how we disseminate our achievements and results as a GeoSense. Then I'm quite thankful to all these efforts. And of course, we have the website. Much more information you can get on our website. And please follow us on the social media. We have Twitter and LinkedIn accounts. We have this project leaflet. So again, thank you for your information, and sorry about these technical issues about the presentation and so on. Thank you.
It was fine. Thank you, Vlasko. We could follow it perfectly. Thank you very much. I picked up on the need for coordination across organizations. That came through very strongly, even from Turnkey, which is, of course, the project I'm coming from. Okay, so now I'd like to invite Irmela, which will be talking about METIS.
Yes, good afternoon. I'm happy to be here and to represent METIS project. Sorry, I don't have a camera, so you won't see me, but I will now share my screen. Do you see my full screen?
Yes, yes, I see.
Okay, and the voice is also fine?
Yes.
Okay, so thank you very much. So I'm here on behalf of METIS project. I'm METIS project coordinator, and I'm working at EDF R&D. I'm expert research engineer. I also have prepared a first slide to introduce METIS project, an overview. METIS, it's an acronym for Methodologies and Tools Innovation for Seismic Risk Assessment, and it's focused on the safety of nuclear installations. The project is running for 4 years. It has started in September 2020, which means we are now more or less halfway, and the project ends 2024. We got funding of 4 million euros from EU. We are all together 15 partners. I will show a list on the next slide. We have 12 partners from the European Union, and also 2 partners from the US and 1 partner from Japan. And also in the project, we have an external advisory board and end users group, which are quite important bodies, but I will come back to it on the further slides. Just for completeness, so this project has been accepted in the framework of the Euratom Fission Call 2019. And the frame of this project is to deal with the whole seismic risk assessment analysis chain, which includes seismic hazard, structural response, and in particular fragility analysis. Then failure and inventory and system analysis, because when dealing with industrial plants, you are not interested in the failure of one component of one structure, but as a networks with an ensemble of redundant and or systems that are used in series, and all this with a final goal of risk quantification for nuclear power plants. Here on this slide, you can get an overview of the 15 partners of this project. I will go to the next one. So yeah, one of the high-level objectives, let's say, of METIS project was to obtain something like a European consensus on best practice approaches and tools for seismic safety assessment of power installations, because clearly we need to constantly update and improve safety as science and new knowledge comes around. And we also have some particular issues to be dealt with, perhaps with respect to civil structures. We do need to consider very high return periods for obvious safety requirements. And on the other hand, our structures, SSC structures, systems and components are generally quite robust and well maintained, which gives us some challenges in structural analysis and assessments. Yes. Just with respect to this, so one of the goals is to implement scientific best practice. In particular, this is why it's very important for us also, on the one hand, of course, to rely on the academic partners, but then also on peer review and the advisory boards of the project. And together with this, end up with approaches that are feasible in an industrial context. And for this purpose, we have a quite large end users group with many industrial and also safety authority partners. And I will come back more on this. So when related to this, to meet all of these goals, we base also our approach on the development and the dissemination of robust simulation tools, so validated and well maintained. So we have a couple of already existing tools and new tools that will result from this project. And another way to disseminate and to go further is the training of new generations of engineers, because there was some special knowledge which is not always available in graduate level. So earthquake engineering and nuclear safety. So one of our focuses is also on training. Then the methods that we are developing our methods need to be site specific, because we are interested in some very particular structures and locations. So we are really interested not only in getting some kind of ensemble view, but in realistic assessments of seismic load and structural response through physics-based models and simulation. This means best estimate assessments plus uncertainty, and then uncertainty quantification propagation through the whole analysis chain. And whenever possible, calibrate and validate the models against data. The data can be observations or measurements. So, and then another important point that we promote here is an integrated approach from the seismic source to the structure. This was generally not the case in the past. It was more partitioned in different disciplines. So we do want to address the full analysis chain from the source to the structure, including seismology and geology, structural and system engineering, risk assessment domains in one comprehensive approach in order to better control margins and the interfaces between the different parts of the full risk assessment analysis chain. Yes. And one important means to obtain this are open source numerical simulation tools. So this project is mainly based on open source tools in order to be able to share the new approaches, to have others help us to improve, and also to allow for easier peer review. So you can see here the open source tools that METIS project develops or improves Many of you might know OpenQuake because it's much used for seismic hazard assessment. And then we also have two finite element codes, Codaster and OpenSeas, and simulation platform, Salomeka, and then a new tool which is an existing open source tool, but it's not yet used by industry or anyone else for risk quantification. It's Scrum. So this allows us to share state-of-the-art with academia and other industry more easily to disseminate the new best practice methods, and also to share examples and application guides. Yes, I'm already coming to the end. Then regarding the final outcome, and another important point, which is the METIS case study. So we developed a full case study which is close to an industrial application in order to assess feasibility and benefit of new approaches for safety assessment, and then the final outcome are the tools and open simulation platforms together with the final handbook and application guides. Yes, that's all I have.
Thank you.
Now, yeah, there was one last slide. I don't know why it didn't appear, just to give you, in case you're interested, the next events. So we have 2 summer schools this year on fragility analysis and on PSHA with OpenQuake, and also 1 training session related to Codaster, and the next plenary meeting will be in Essence. So if you're interested, reach out for us. And yes, thank you.
Thank you very much. Again, a very different angle with your focus on safety and assessments, using different disciplines to get there. Thank you very much. Okay, so we can start with opening the floor now, and the idea is to get basically the reactions of participants now. Your reactions, your comments, any thoughts, and so on. So if anyone has any questions, please let us know. To start things off, I would ask one question to the presenters themselves. Now, I know 2 of the projects are close to completion, and the others are sort of midway through, if I could understand correctly. So what challenges have you come across, or are you anticipating coming across over the course of the project? Yes, Ratko?
Okay, thank you. Yes, I can now say a few words about the crisis. I mean, yes, your question is quite good. I mean, what were the challenges? And the main challenges was that most of our partners are coming from research institutions. As I can see in the other project also, many are coming from the research institution, and somehow we can understand each other, even if we have different ideas, different approaches, whatever. But the real challenge, I think, for our project was how we can approach, how we can convince the disaster management authorities, I'm speaking, let's say, for our country, in order to implement some of our knowledge or some of our achievements. In our project, we have one, let's say, representative from that side, I mean, Crisis Management Center. And we were, at the beginning, very spending a lot of time to convince them, because they do have their own system for management of different type of crises, but it is very closed. They cannot open it and just to implement some of our, let's say, up-to-date information on knowledge. And this was and still is the main challenge. So far, we have succeeded only to implement one small module in their system. It is actually Macedonian national system for management of crisis. Just one small module in order just to little bit improve the quality of the data they collect for the critical asset, let's say basic services and critical infrastructure. So, but this very small step toward the real implementation of our achievements and results that we have so far. I think we have to work a little bit to become our results to become much more friendly to be used for the end users, or in our case, first responders, national crisis management authorities, and so on. So when we have a lot of research institution in one project, is very good. Okay, we can discuss, we can make analysis and so on. But the final goal is, okay, what has our society has benefits? And this is a real challenge, how we can convince them to use it this type up to date, let's say upgraded analysis results, or whatever it should be. So this is, I think, for our project, and I can see for the rest, quite big challenge, how our results should be fully implemented or partially implemented in the national management authorities and so on. So.
Yes, would the others have anything to add to that?
Yeah, I mean, I think what Vlatko was saying is also, at least in parts, true for Turnkey. During the run of the project, I think the biggest challenge was the COVID situation, which was really making during the last years interaction between the different partners quite difficult. I think we have somehow managed it, but it could have gone much better, and it would have been better also with our results, because we had problems with the test beds to install stations, because the people could not travel, they could not leave their institute, or even not going to work, and all these problems. But as we were coming from our project from some ideas to the point that we say the things are working, the project or the result is something which is working and which could improve many things. Now what is at the moment for us maybe the biggest challenge is to decide what of the products we really can use in future, and where are we getting funding to make the last steps, really to have a product which one can give to the different authorities or stakeholders. At the moment, everything, it's running in the test bed, it's running under some special conditions where all the people who have developed it had always a chance to debug maybe there and there's the one or the other point. But we will need time and money to go to the final product, and what parts of the results one can really then put in a final product. These are at the moment our biggest problems to find out.
Irmela, I think Irmela had her hand up, or?
Yes, I just also wanted to say that at METIS project, I think we have identified similar challenges as Vlatko. I would say an overtake of the results of our outcome by end users, because of course it's nice to develop for years nice scientific approaches if at the end they are not overtaken by industry and accepted by safety authorities. So for us, I would say the frame is twofold. It's on the one hand have results that are known and sufficiently user-friendly, so that industry wants to take these approaches and use them, and on the other hand develop scientifically good practice, and so that safety authorities would accept these methods, because they can only be used if they're accepted by safety authorities. So I think we are not at the end of the project. So of course this challenge is one of the challenges that we identified at the beginning of the project, and we are still working on it, and I cannot say whether we are close or far from it. But one of the means was, on the one hand, of course, to have industry in the end users group and also in the project, and then to have also safety authorities or experts from safety authorities in the end users group and in the project also. And then one of our means, I hope, that will facilitate the overtake and share are the open source tools, because they can be disseminated and then they can be used by anyone without any licensing or. Yeah.
Yes, thank you. It's the translating from the research to the actual implementation, isn't it? We're all talking about that final phase, basically. Konstantinos.
Thank you. Well, we have faced the same problems as Latko has described, and Johannes and Imela. An additional problem we had was due to the fact that we aim to cover cross-border areas also. So harmonization of protocols, of methodologies, of the numerous factors that are involved in hazard and risk assessment had to be done. But the main obstacle, the main problem were restrictions for data exchange in real time. So for some of the data, not for everything, but anyway, we found ways to overcome the problems and we are moving forward. So hopefully we will successfully implement to complete the project. If not in time, at least a couple of months later, maybe we will see.
Thank you. Very, very interesting. Okay, I'd now like to open the floor to our participants. So we'd be very interested in your comments. I know that we have a mix of people from both seismological institutes and academia, but also from municipalities and civil protection. So we'd really be interested in hearing, did anything strike you? Did anything stand out? Any thoughts on what you heard today? I suppose one of the things that, well, it's what we've been discussing. So it's how do we make this webinar, of course, is one of the things we're doing to try and push the research and the products to sort of to be considered, to raise awareness about what we're doing and to be considered by practitioners in the field of emergency services. So I suppose it's how do we render them more relevant and what can be done to make sure that maybe there are some improvements to be made so that there's more benefit that can be gained from using any one of these products. So Niels, I think.
Thank you. Yeah, just a comment. First of all, I think all these projects are very interesting, very well done. I'm just wondering, like, each of these projects have their specific scope, but how would you connect it to other parts that are related to earthquake risk? Like you have something before an earthquake strikes, you have it during the earthquake, and you have it after an earthquake. How would you connect that?
So I'm not sure I understand the question, Niels. So
how would you connect the results of the research and the projects that they have done with other parts of earthquake risks? For instance, myself, I'm active in earthquake forecasting, so that's everything before an earthquake occurs, right? But I see synergies with all the rest that has been shown here today. I don't think it's something that's very isolated. I believe it's an end-to-end process, or it's an end-to-end spectrum. So I don't know how the experts here see, for instance, these synergies.
I think if there are algorithms and if there is information about earthquake forecast, this could be implemented as part of the hazard calculation of what we have in Turnkey. And if the community is accepting this and saying this is really something which is working and there is no problem to include this in the hazard calculations of an area, to say, okay, the probability that a big earthquake is coming or is higher now than 3 months ago or whatever. This one can take in. This is no problem. And I think also what I was showing is that all the different information is coming together, and you have your hazard calculations, and you say, okay, the what probabilities that we have here an earthquake of this and this size in the next 100 years or whatever is so and so high. This can be used by the authorities for defining the building code in this and this area, and to say, here we have to take this in account. And then the next step is, of course, in the case that there is an earthquake, to have the early warning, that one can maybe stop somewhere, some elevators, or that one can stop the train, that the train is not going in a tunnel or whatever. And there it's, of course, physics limiting the whole thing. You have in the area direct where the earthquake is striking, you have no chance to do anything. You can, in a middle distance, where the effects are still disastrous, but the waves need some time to reach this area, there you have a chance to make some warning, and this one can implement, and such things we have implemented. Yeah, and then, of course, it's very different from where at the end the earthquake happened with respect to the relative distance to your area which is under risk, and how the area may react if an earthquake was happening north of the town or south of the town or whatever, and in which distance. This may give a total different shaking behavior of your area, which gives then, for example, the first responders a much better information about where they expect larger damage, less damage, where they have to send in the first moment the rescue teams and such things. So I think that we are taking care of all the 3 or 4 different steps.
Sorry.
Oh. No, I just agree, and I also see these synergies, and I would love to find people who want to work on this, to be honest.
Excellent. Okay, I'll be talking about sort of how to follow and keep in touch. So maybe we can go into that at the end and try and start off some of these synergies. Barbara.
Yes, I'm actually from Youth Center, so I don't know whether I'm entitled to say something about today, because as Youth Center we have been involved in 2 of the projects that have been presented today, Turnkey and Crisis, which are quite different projects in terms of, final aim of the project. The goals of the project are completely different, also, is completely different also the size of the project, because Turnkey was quite a large project with several partners, whereas Crisis is a smaller project, is on DG Eco, has been funded in the DG Eco framework. But by the way, both of the projects have something in common, which is the fact that they both produce platform and system that could be used. And the point is exactly the one that Vlaco was making before, earlier on, but also Johannes, is how to get the civil protection institution in general to use these products as they have their own system. As Youth Center, we are a center of excellence of the Italian Department of Civil Protection, for instance, and they have their system which are fully customized for them. And I mean, I can see Agostino Goretti, which is one of our colleagues in the Italian Department of Civil Protection, who has joined the meeting. So he might confirm what I'm telling right now. And I think that, I mean, as they have, since they have their own products, their own tools, which they've been trained to use and whatever, we should invest on providing some services which could be connected with the tool that they already used, are based on our platform, but we could send some information, some data, the one that they are interested in receiving, I mean, without, I mean, considering the possibility of having the tool that the project has been developed fully adopted by, I mean, at least from the civil protection, which are national based. Maybe some local civil protection might. For instance, in Turkey, we had test beds, and the stakeholders from the testbed have been heavily involved in the development of the platform. So the platform could be useful for them, and also the solution could be replicated somewhere else. So we have also this chance for the sustainability of the platform that we have been developing. And we have been investing quite a lot in this kind of development. But maybe we could also work in terms of providing some services for, you know, bigger institutions, national based. I mean, that they will keep going on with their own system, but they could have some services provided by the product that we have been developing in our projects. So, two-way. Somehow, some institution might adopt our solution, and others, which are bigger and then they have their own tools, might do some tests to see whether our services are of interest for them.
But it means we also need to be flexible to adapt to what they want, basically.
Yeah, that's right.
And to whatever barriers they have, of course. What about the others? Would you have anything, any thoughts about integration to the other presenters, maybe? Konstantinos, yes?
If I may add to what the rest of the speakers said, with which I absolutely agree, I would like to add to what Niels asked, that earthquake forecasting is, let's say, a complementary action to what we do. For instance, everybody aims, among others, to support prevention. So forecasting could very well help the authorities to prioritize interventions, because they cannot intervene everywhere at the same time. You know, there are funds required, so on. So forecasting could very well help prioritize actions and help the authorities justify their decisions. Why here and not there? And having said that, the systems we develop are decision supporting systems. As long provided that they prove to be dependable, reliable, provided that they will prove that they provide accurate and reliable information. That would help the authorities justify their decisions during critical moments, because there's always responsibility and accountability. And sometimes civil servants may be reluctant to decide this or that. This is another aspect. I'm just, putting this on the table. It could help them. It could relieve them from this burden. Up to a point. Okay. Thank you.
Vlatko, yes?
Okay, now same as Konstantinos, I will back to the discussion of Niels or question. Yes, seismic forecasting is quite important aspect or first step toward building the seismic resilient society that we all want to achieve. But only earthquake forecasting is not enough. Even if you know that some earthquake will happen, you have to know what kind of buildings, what kind of structures, how many population, what kind of infrastructure you have on that region in order for different type or different level of earthquakes that you have to know in advance what will happen, what are the consequences on the, let's say, structures, buildings, people, whatever, services and everything. You have to know in advance, then you can have enough, how should I say, information that you can manage the resources to support, to help the appropriate, region that has been hit. So these are the things that we are trying, in the different way, all 4 projects that we have presented. It's not enough just to know, okay, we know that the earthquake will happen, either in North Macedonia, Albania, or Greece, or just 6 months ago, there was an earthquake. I will tell you the real example. On the border between Greece and North Macedonia, close to Bitola, and it was 10 kilometers, I think, in the territory of Greece. But the most damages, or the most consequences, were appearing in Bitola, in North Macedonia. So it's not enough that, yeah, we know that earthquake will happen, but what are the consequences on our infrastructure, on our structure, on the people and health services or whatever? So, and then the disaster management authorities, the first responders will have enough information to manage or to deploy resources to hit areas. So I think, yes, forecasting, it's very important, and it's a first step in the later on organization of this management of the consequences of this natural disaster. So yeah, of course I agree, and yeah, this is quite important, and we are all keen to work in the earthquake forecasting. Maybe not forecasting, but we are seismic hazard assessment and so on. So yeah.
Just a little point coming from Turnkey, something that Civil Protection told me during our interviews was that they would use something like this to actually identify the citizens that are more at risk. So it's about designing and targeting information messages to people who might be living in buildings that are more at risk. So it's the correct and the more effective deployment of resources, again, investing where it's most likely to make a difference. Johannes.
Yeah, not only since we have European Commission projects, it is clear that seismologists have to work over borders. And I think Vlatko is really on an important point there. We as scientists, we are cooperating over borders since 100 years, and we know that seismic waves are not stopping at borders. But this is also true for, of course, for all the local authorities, and they have to cooperate. Otherwise, it's disastrous, and it can be easily disastrous. But especially in earthquake-prone areas like the whole Balkan, and where you are quickly in another state, and this is just. It does not go otherwise than that people have to work together. And the same is also true what the remarks about decision support systems. There comes, of course, beside earthquakes, there comes in addition the components that earthquakes can have effects which are at the end initiating other catastrophes. A landslide can block a river and you get flooding and all these problems, and all these natural catastrophes can influence partly each other. And therefore, of course, a decision support system has to be multi-hazardous. So one has to take also other hazards in account and There I know several people and groups working on new solutions and ideas how to combine this. This is the next step, of course, but as good and as important this is, first, of course, let me say the seismologists have to do their homework for the seismology part alone, yeah, and the other components are then have to come together.
If there's anyone from the local authority side of things or civil protection, please let us know what you think about this discussion, or any other comments that you may have. One of the things that we actually asked was, what would people anticipate that they would need to be able to integrate these solutions? I think it was one of the things that we thought at the end of the project, this is sort of one of the next things that we need to think about if we're going to develop things further. So integration with, like Barbara was saying, with whatever people already have, because it's, for people to adopt new solutions, it's about two things. Firstly, it's about the benefits. They need to see that it's going to make a real benefit, but the other thing is about overcoming the barriers. So, and the barriers could be one of these things. The integration is difficult, it could cost too much, that's another thing, or it would require a lot of training time, and not everybody in the organization could use it easily, that sort of thing. So the user friendliness that Vlatko was talking about, for instance, was something that was mentioned a lot. It needs to be something that can be used by any operative very quickly, and it needs to be very intuitive, because if it's a crisis situation, it needs to be easy to use and quick to use. Any other thoughts? Yes, Marco?
Yeah, maybe I have a question that I would be interested actually to discuss. It's actually not strictly related to the, let's say, scientific aspects, but we have 4 projects, and as many of the European projects, they have a beginning and an end. And I think that what is very important is to make sure that there's a legacy that every project leaves, because in this way, the following projects can leverage from what it has been learned, from what it has been created, right? So it's a way to make sure that the project is not ending after 3 years or 4 years, but it's in some way living forever, because other people are taking over and using it. So I would be interested in which way the different projects are, let's say, making sure that what they are doing, it can be also used by other projects, and therefore there's a way to make sure that other products are growing on top of them. So, for example, just to give you, I'm involved in the METIS project. I work with Irmela, and I work at GEM, that's the organization to which I belong to. And at GEM, we developed the OpenQuake engine, which is an open source tool. And most of the things that we are developing within METIS, hopefully will be added to the OpenQuake engine as new functionalities. And so that's a way, in our opinion, at least, to make sure that what we do in some way will be available later on and will be eventually extended by other people. So I would be curious to understand if there's a mechanism that also the other projects have been thinking in order to try to say, spread what they've been doing and make sure that that the good stuff that I saw, because I saw very, very interesting things in all the different presentations, can be used, as you said, in the application, but there's a way also to make sure that maybe the same project or other people will be able to improve even further, because that's clearly an advantage for everyone, right? rather than keep on reinventing things to make sure that we build on the projects that we've been doing and we create even more interesting and more advanced applications and things.
Yes, thank you, Marco. Very good point. Barbara.
Okay, I don't know. Johannes is here, so he can tell whether he share my.
You can just
my
go
opinion.
ahead.
Can I? Okay. Right. For Turnkey, I would say that the strong point of this project, at least in my opinion, is that is based on test beds. I mean, and the solution is very replicable somewhere else. So the product that we have been developing so far can be used in the test bed. That's why there was a big, quite a long part of, well, the first part of the project that has been invested in collecting the needs from the local stakeholder, where we had the test beds. Silvia was heavily involved in this kind of activity. So, I mean, I think that the added value of the solution that we have been suggesting in Turnkey is that is replicable somewhere else. It's immediately usable from the local stakeholders in the testbed area, where we are going to install the platform, and then it could be replicated somewhere else. So, I mean, in my opinion, the project results can survive because of this. But nevertheless, there is still the possibility of having some services provided to civil protection, larger civil protection, which will not adopt fully the solution because, as I said earlier on, they have their own tool. For instance, here connected, I can see Agostino Goretti from the Italian Civil Protection Department and Alessandro Ballini from Lombardia region. So we are talking in both cases in very large institutions that do invest a lot in, you know, having their own tools. But nevertheless, we could try to get involved with them to test the solution that we have delivered during, I mean, the projects, to see whether there is something that is of any interest for them, just you know, to use some of the first services. Of course, going through sort of testing phase, because I mean, as I said, we are talking about very large organization, very well established. So I mean, it's we need to go through sort of testing phase.
Thank you, Vlatko.
Okay, that's very interesting questions, and I don't know if we can have a universal answer from all the projects, but yeah, in every project, this is the main question. What will happen with the results after the project end? But I can speak about our experience. So actually, we started with this collaboration with, first of all, with EU Centre and the rest of the partners in the previous project. So, for example, this crisis is like continuation from the previous one. We have Infranet from the same mechanism of funding from the UCPM, DG ECO that Barbara already mentioned. Over there, we were focused on the bridge structure in 3 countries, different countries, Israel, North Macedonia, and Italy. So now we are going further. We see that we can achieve something. We have a good result in the previous project. Let's little bit widen up the main goals. Now let's face to the basic services like health facilities and school buildings. Now in this case, in crisis, we already built a database, very detailed database. we use some of the GM models, I mean tools, and we have very details regarding the structure itself of these buildings, of schools, of hospitals. So we will share this information and database with the authorities. Why they need to build another database for let's say, Ministry of Health. This is quite enough detail. So not necessary for them to build another database, let's say, for the border region between, I don't know, Macedonia, Albania, or between each country, any country. We already have it. If you have new hospital, just update it. It is not necessary to build another one because it's quite detailed. So that was one of our purposes. So again, we implemented the one hazard model, which is quite new. Okay, now you have a new one, 2020 maybe published. Just implement this model, not necessary to change the whole another project. So I said that, yes, that's very important to share all this information. We have a website and we share this information to the stakeholders, not just in Macedonia, but in Greece and Albania. So no need to do the same thing once again from the beginning. So this is, I think that's why your, your discussion was quite important in order not to do the same thing again from the zero. We reached somewhere. Okay, now change it. I mean, we did it for school, for hospitals. Now we can do for governmental buildings. So just updated the database. No need again to do it. We are building web-based platform. No need another web GIS, I don't know, structure. This is working, just update it. That was our main goal. I was trying many times to convince the Center of Management of Crisis in North Macedonia to implement. I succeed so far on this small module, and I hope to the end of the project, even after that, to implement other modules. So which are, as Barbara mentioned, I'm not touching their services, I mean completely. Just in their system to upgrade it, some small modules that can be much more efficient and up to date comparing to what they are using using nowadays. So that's I'm not changing the whole system because it's very complex. You know, national crisis management is quite complex platform, but only small modules that can be used from the results from crisis. So I think this is our experience. I'm not saying about the rest. Thank you,
Vlatko. Konstantinos.
Thank you, Syria. Thank you, Marco, for the question. As Vlatko suggested, we also capitalize on previous projects. We had a project which ended in 2015, Scientific Network for Earthquake, Landslide, and Flood Hazard Assessment. The website is still on, and all the deliverables describing the current status at the time, state of the art, and so on for all three hazards in Greece, Turkey, Bulgaria, Romania are still there. I mean, everyone can have access to that. We are also fortunate to closely cooperate with major stakeholders. One of the partners is the Hellenic Earthquake Protection and Planning Organization. So Greece is covered, but AFAD, for instance, from Turkey, has expressed a great interest in adopting the platform we are developing, which will be freely distributed, Rapid Earthquake Damage Assessment Platform, which will get information in real time from all monitoring networks in the area, except Greece, Turkey, and Romania. And having said that, NIEP also, the National Institute for Earth Physics, is also interested in adopting the platform. And we have a very close cooperation. I mean, their needs and our constraints are guiding us towards developing what we are developing at the moment. The smartphone app we are going to develop is going to be distributed freely over the Google store. And obviously the educational hub will be there on the website of the project. So anyone can have access to everything and get it, use it, always can contact us if he needs further information or support or anything. So I think that all projects are looking have this perspective to their outputs, because all projects want to convert them into results. So it's a great result to have scientists not participating in the project being interested and asking for your outputs. It's a privilege and an honor to have that. So thank you.
Thank you, Konstantinos. Johannes. You're muted, Johannes.
Yes, I just see it. Regarding Turnkey, beside what Barbara was already mentioning, the test beds, which will, with the instrumentation and some installation, survive and show how and what one can do. There was quite a lot of development of software with respect to the instrumentation and installation of the instruments and data exchange, and there were developments which will be part of future distributions of the vendors of the instruments and of the people who are staying behind the software for data exchange and so on. So this is already more or less done, and another part is that, of course, what we were setting together, what I call the engine of the different modules as a state of the art, even there we have already started to use it in other contexts because the whole thing is modular built up and can be used also in other contexts. So there I don't fear so much that one is saying at the end, yeah, and what was the outcome? We are there, I think, on a good way. What we wish, and this is what I was saying before, is that maybe more the whole system itself will survive and not only bits and pieces. But this will only work if there are some support, financial support is found. This cannot be done by the institutions. They cannot go in and invest there in some product, millions of euros in over years without knowing that there is a positive outcome. And this only works if the support from the community and of the stakeholders somehow is coming in, yeah, that the stakeholders are saying, yes, this is really something we would like to have to run. Please implement this part in and we are paying for the implementation. Yeah, this cannot be done on just voluntary basis. And there we are at the end then also depending on the community and on the general societal situation in the different countries.
Perfect. Thank you, Johannes. And as you said also, like Vlatko said, there is interest in Turnkey. We had people that we were interviewing saying we're very interested in this, we'd like to see this actually available to us, but it's how to get us to that point, to meet them at that point. Are there any other comments? We're coming to close to the end. Are there any other comments? Something that would be interesting to us is any suggestions for improvements? Anything else that the project should be taking into account? Maybe not Turnkey, which is practically almost finished now, but maybe also for the others, anything to consider going forwards? Okay, so do the speakers have anything to add before I start to conclude the meeting? No, okay. So the last things I need to say here are, so first of all, thank you to everyone for participating. Thank you to our speakers for all your interesting presentations. Now, what we're interested in going forward from here is that this doesn't, as we've been saying, this doesn't stop here. So we'd like to get a conversation going. We'd like to create synergies. We'd like to put people in contact with each other. So what we'll be doing from our side is you'll be receiving an email with links to the web pages, to the social media of the different projects. for you to look up more information, and please do follow the different projects on social media and so on. The other thing that we'll be doing is that we'll be sending you the email addresses of all 4 speakers. So if you would like to get in touch with one of them specifically about any of the projects, please use that email address, and please do get in touch. We'll be very interested in hearing from you. Is there anything else? Anything else anyone would like to say? No. Okay. Well, thank you very much. This was, I really enjoyed it. So thank you very much, everybody, for taking part and for the very interesting discussion afterwards. And I wish you a lovely evening.
Thank you, Celia, for the invitation.
Thank you.
Thank you, Celia. Bye, everybody. Bye-bye.
Thank you.
Bye.
Bye.
Bye.